True or false? 31 is a composite number. A composite number is a number which is not prime, and therefore it will have a factor besides 1 and itself. A trick in testing whether a number is prime or not is that we only have to check prime numbers up to the square root of the number. Now, I don't know the square root of 31 offhand, but a square number close to it is 36, and the square root of 36 is 6. So if I just check prime numbers up to 6, we'll be able to tell whether or not this is prime. 2 is the first prime number. It's a special prime number because it's the only even one. The next prime number is 3. The next one is 5, and the next is 7, which is bigger than 6. So we only have to see if 31 is divisible by 2, 3, or 5. It's not divisible by 2 because it's not an even number. If we add the digits, 3 plus 1 is 4. That's not divisible by 3, so it's not divisible by 3. It doesn't end in a 0 or a 5, so it's not divisible by 5. So 31 is a prime number, which means it's not composite, and therefore this is a false statement. True or false? 44 is a prime number. This is false. We can tell that immediately because 44 is an even number. The only even prime number is 2. All other prime numbers are odd numbers. True or false? 1 is a prime number. This is false. The first prime number is 2. I refer you to the definition on the WISP. Prime numbers have two factors, 1 and themselves. So for example, 23 is a prime number. It has two factors, 1 and 23. And 1 times 23 is the only way of making 23. So 1 doesn't have two different factors, and therefore it's not prime. Nor is it composite. 1 is a special number which is not prime and not composite. We want to choose the composite numbers from the list below. The highest number here is 31. 36 is the next square number above 31, and if we square root that we get 6. So we only need to test the prime numbers 2, 3, and 5 with these numbers. Looking at 23, it's odd, so it's not divisible by 2. If we add the digits, 2 plus 3 is 5, and that's not a multiple of 3, so it doesn't divide by 3. It doesn't end in a 0 or a 5, so it's not divisible by 5. So this one must be prime, and therefore we can cross it from the list. 25 ends in a 5, so it's divisible by 5, so that's a composite number. Looking at 27, 2 plus 7 is 9, which is divisible by 3, so it's divisible by 3, and therefore composite. 28 is an even number greater than 2, so it must be composite. 30, I know, is 3 times 10, and therefore that's composite. And 31, we established earlier in this lesson, is prime. So these are the composite numbers. List all of the prime numbers between 40 and 60. 40 and 60 themselves are clearly divisible by 10 and therefore are composite. All of the even numbers will also be composite. So let's just consider the odd numbers. 41, 43, 45, 47, 49, 51, 53, 55, 57, and 59. Now some of these I can eliminate straight away. This is clearly divisible by 5, as is this. I happen to know that 49 is 7 times 7. 5 plus 1 is 6, which is divisible by 3, so 51 is divisible by 3. 5 plus 7 gives us 12. 12 is divisible by 3, so 57 is divisible by 3. But I believe all of the numbers that we're left with are now prime numbers. If we want to be absolutely sure, then the next square number after 59 is 64, and the square root of 64 is 8. So we need to check the prime numbers up to 8. Obviously, we removed all the even numbers, so we don't need to look at 2. I've already looked at these numbers in terms of 3. None of them end in a 5. And the only multiple of 7 left in the list was 49, which we crossed out. And therefore, we are left with the prime numbers.